Entropy and disorder. We've learned that entropy is a measure of useless energy. There's another way to think of entropy that is critical for understanding life. Entropy is a measure of disorder. When the rock is on top of the cliff, its energy is all in the form of potential energy. The energy is due to the rock being in its precise location. The energy is very well ordered since it is concentrated in one place. When the rock hits the ground, its energy turns to heat. That heat becomes broadly dispersed. The energy is no longer concentrated in one location, the rock. It is spread throughout the ground, air, and the rock. The energy has become disordered, making it useless to do work. While we have seen that entropy increases with the disordering of energy, it also increases with the disordering of matter. Increasing disorder results in increasing entropy. This applies to objects, including atoms and molecules. If every atom is locked in a specific location, making it very ordered, entropy is low. If atoms can move around to many places, making them very disordered, entropy is high. When these red particles are bonded, they have fixed positions, they are very ordered. The four small particles act like one larger particle. They are more ordered since they all move together. They cannot move to separate locations. Their entropy is low. When the bonds between them are broken, the particles are free to move about independently. They have become four separate particles again, which can all be in different locations. They are less ordered. Their entropy is high. In general, as particles bond together, reducing the total number of independent particles, entropy is reduced. As they break apart, creating more independent particles, entropy increases. On the left, we have one particle which has less entropy than the four particles on the right. The entropy of the universe increases with time. Its energy and matter become less ordered. But life locks a very large number of particles into fixed positions. It is very well ordered compared to dispersed matter and energy. Life has low entropy. As an organism grows, its entropy decreases. If entropy is always increasing, how is life, which requires reducing entropy, possible? Discuss. For many years, scientists thought that the rule of increasing entropy did not apply to life, that life was an exception. Now we know that life follows the same rule. As life grows, it becomes more organized and its entropy decreases. But life increases the entropy of its environment by an even greater amount. In total, the entropy of the living system and its environment always increases, obeying the rule. Accomplishing this requires a consistent source of energy with low entropy. Any thoughts on the source of low entropy energy to support life on the surface of Earth? Discuss. Life on the surface of Earth is made possible by a steady influx of low entropy energy from the sun. As you will learn, that energy moves through the various trophic levels of the biosphere, slowly increasing in entropy and becoming less useful. Eventually, all that energy becomes heat, which is then radiated into space. Life exists due to that flow of energy and entropy. The energy that arrives from the sun is balanced by the energy emitted by Earth, keeping the planet's energy constant. The difference is that the energy arriving from the sun is low entropy, while the energy emitted by Earth is high entropy. For each photon of light that arrives on Earth from the sun, 23 photons of light are emitted by Earth into space. The energy flow is balanced, but the increase in the number of photons represents an increase in disorder, or entropy. That increase in the number of photons represents the flow of high entropy energy away from Earth, keeping Earth from overheating. Global warming results from the slowing of the flow of high entropy photons from Earth. That is due to greenhouse gases absorbing and re-emitting those photons, delaying their departure. That raises Earth's entropy. The result is the global warming we are experiencing.